好，我想时间差不多哈，那我们有稍微 delay 10分钟开始哦，那人陆陆续续进来了哦。好，那首先吴副校长，陈理事长，然后以及在座的各位大家早安。那我是本届 Rocling 举办的Conference Chair 张永纯。那首先欢迎各位来到台北医学大学，好。那第34届的 Rocling 的会议，其实在这个2年的疫情之后，那恢复了实体，那所以我看到大家都蛮踊跃的到了现场，这是非常开心的事情。那也可以利用这个实体的过程中，解封了，让大家在这个过程中有一些互动。那这也是第一次这个 Rocling 在医学大学举办，这也是蛮难得的一个经验。好，那首先我们就先邀请我台北医学大学吴学信副校长来给我们致辞，揭开本届的序幕，谢谢。
好，谢谢我们今天大会的主席永纯副书记长，还有我们中华民国应该是计算语言学会的陈理事长，还有我们戴执行长，还有在座各位的一些先生女士，还有各位贵宾，大家早安，大家好。那今天真的很荣幸能够代表台北医学大学，欢迎大家莅临我们台北医学大学的大安校区。那我想在过去33届的努力之下，奠定我们在不管是语音或者是在自然语言的处理方面，都有相当卓越的一些成就。那今天是我们第34届的我们的自然语言与语音处理研讨会的盛会。那就从刚刚我们主席所提到的，在过往呢，我们因为疫情的关系，所以都是实体没有办法举行，透过线上。那这一次呢，我们再次恢复实体的这样子的一些会议，希望今天的交流能够更为热络。那我想在最近人工智慧还有大健康产业的一个发展，我们一直在强调精准。那所有的精准都建立在于数据的分析，而数据分析呢，不管是在自然语言，不管是在语音的处理方面，都非常非常的重要。所以我们现在努力的发展的，不管在人工智慧，不管在健康医疗，不管在新药开发，或者很多的面向，其实都需要有这样子的一些自然语言跟语音处理这样子的一些更新的技术。那我在座看到很多我们的年轻的心血哈，那这是一个非常好的一个现象。那表示大家对这个领域呢越来越有这样子的高度的热情。那台北医学大学是一个医学大学，那我们在很多面向的一些发展都投入相当多的心力，尤其在政府接触的精准健康的这个方面呢，我们希望能够借由人工智慧，从自然语言从语音处理方面呢，能够跟大家一起来共襄盛举。我们在所有这样子的一个精准健康大产业的一个发展面向呢，都能够有更卓越的一些成就。所以我预祝今天的活动还有今天研讨会顺利成功，谢谢大家。
好，谢谢吴副校长。那接着我们以热烈的掌声欢迎陈理事长来为我们致辞。
好，那副校长哈，那永存老师哈，那各位师长、各位同学，大家早哈。那今天非常高兴哈，就是说台北医学大学哈提供那么好的场地哈，让我们这个各位老师、各位学生都可以很方便的来参加。那的确就像副校长讲的哈，这是我们这几年来第一次走向实体哈。那也就是说我们在疫情的期间，其实很多的会议我们都是在线上举行。那 Rocling 呢是我们这个中华民国计算机语言学会的一个机械型的会议，我们每年都举办一次。那在这个会议里面呢，其实我们都会邀请国外的专家来这边发表 keynote speeches。那像今年我们就请2位日本教授来这边发表。那当然我们也有很多很精彩、很优秀的论文在这2天的会议里面会来发表。那我希望借由这个会议的这个举办还有各位同仁的参加那就像副校长讲的我们自然语言处理、语音资料探勘等等的技术能够有更多的交流。那未来跟国内的产业或是一些研究单位那也有 更好的一些合作希望能够发展更能落地的一些技术，然后对我们的台湾或是世界更有影响力。那在此呢，仅代表中华民国计算机语言学会祝这个此次的这个 Rocling 这个圆满成功。那各位与会的师长各位同学健康喜乐谢谢大家。
好，谢谢理事长的支持。那我们利用这个时间来拍一个这个团体照，好不好？好，那我们看这个地方吗 ？Good photo。有不对。好，谢谢。
Good morning, everyone. Welcome to Rocling 2022. It's my great honor to be a session chair for this keynote speech. I'm Minyu Day from National Taipei University. It's my great honor to chair this session. And we have our guest speaker, our keynote speaker, Professor Makoto Kato from Tsukuba University. And I first met I first met Professor Kato for more than 10 years ago. I first met Professor Kato at NTCR 11, and I consider Professor Kato is a rising star in the area of information retrieval. Because at NTCR in recent years, Professor Noriko Kando, Tetsuya Sakai, and Makoto Kato contribute NTCR a lot, and I learned a lot from Professor Kato. And Professor Kato will tell us about the recent research on information retrieval. Ladies and gentlemen, please welcome Professor Kato to give our keynote speech. Thank you so much.
Thank you very much for very kind introduction, Professor Day. So it's my great pleasure to have this keynote speech. Thank you for inviting me, Professor Chang, and congratulations for the success of the conference. So today I'm gonna talk about this topic, matching text with data for evidence-based information retrieval. So as Professor Day said, I'm majoring in the information retrieval. And today I would like to introduce my recent work on data-driven information retrieval researches. About me, let me introduce myself briefly. So my interest in information retrieval, I'm especially interested in retrieval algorithm. And as Professor Day introduced, I'm currently serving as an NTCR General Co-Chair. Probably some of you may not know NTCR. So it's a kind of, frankly speaking, it's a workshop of shared tasks where we share our knowledge about information access researches, including information retrieval, text summarization, and question answering, and so on. And I have been involved in this event for more than 10 years, I think, and have organized web search, mobile search, question search, and dataset search tasks. And I also mentioned that I'm currently luckily serving as a CIR 2023 PC co-chair. This is mainly thanks to General Co-Chair. I hope they also attend this event. And thank you so much, Professor Chen, Du, and Professor Huang. And the reason why I mentioned this is that this will be held in Taiwan next year. So if you have some very nice research topics you have, please consider your submission, your paper submission. And for your information, I uploaded my slide at this link. So if you are interested, please visit this website to get a slide. So Rocling 2022. All right, so this is a kind of advertisement. Yes, the website is ready and you can find some schedule here. So yes, please mark your calendar and from your submission. All right, so let's start by introducing some current problems on the current web. So as we know, there are many problems on the web now, and one of them is, I think, it's a misinformation on the web. So the inventor of web said it's too easy for misinformation to spread on the web. And in my field, information retrieval field, the famous researcher Ryan White from Microsoft surveyed about the search engine result, and he found 55% of the top ranked search results are wrong for medical Q&A queries. So this is a little surprising. If we ask some question about, for example, COVID-19, or if you have some illness, then the most of the information you can get from search engines are wrong. And about 97% of people answered they have encountered fake news. So this problem is very, very common in the modern web. And here's some example. So some people said vitamin V may help improve COVID-19. But in the end, according to Reuters and some expert in US Medical Institute confirmed that vitamin C is not very effective for curing coronavirus. So there are some wrong information on the web. And at the same time, we also have some overclaims or disinformation. So here's an example of Vote Leave campaign in UK. So in UK, as you might know, they left EU, and this might be led by the Prime Minister Boris Johnson. He said they have to pay a lot of money per week to EU, and he said it's a kind of wasting money. But it turns out the UK Statistics Authority concluded on someday. They said it's not. It's partially correct, but it's not accurate. So this huge amount, 350 million pound, is total, yes. But this didn't take into account the rebate or other flow from EU to the UK public sector, and they conclude that this is potentially misleading. So this is not really wrong information, but this mislead people, and in the end, they left EU. I don't talk much about the precise definition of misinformation, disinformation, but for people who don't know much about this category of information, I want to show this slide. So there are the classes of information disorder. So one class is a false information. This includes misinformation and disinformation. And there are another type of information disorder, which is harmful information. And this includes disinformation and malinformation. So I mentioned misinformation, disinformation earlier. And in addition to these kind of information problems, we also have evidence-less information on the web. So some people say chocolate help you lose weight, but some people argue that yeah, it just makes you fat. I'm not sure which is true. And you can also find some interesting rankings, like the world's 50 best food. The best food, according to CNN, is masamang curry in Thailand. Sorry, I don't know about this food, but this is ranked at the top. And according to Forbes, the world 20 best city in 2022 is introduced. And the first one, the top ranked one, is Edinburgh in Scotland. Can you agree with this result? So why isn't it Taiwan food? And why isn't it Taipei? I believe they should be ranked at at the top. So I think these kind of rankings are based on some people's opinion or biased view or a small number of experts' opinion. So these are interesting, but evidence-less, I think. So the major approaches to this kind of problem include consulting with experts. And this is kind of major approach, I think. For example, YouTube have policy that if they want to decide whether information is misinformation or not, they rely on expert consensus from both international health organization and local health authorities. So this is maybe first method we can take. But of course, the number of experts is quite limited, and we cannot always consult with such expert. And second methodology might be get help from citizen effort. So one of the examples is the Snopes.com, and they have some board member, and they survey whether information is wrong or not, or disinformation. And the last one might be of our interest, I think, because we are working on some technologies to support people. So some people already propose some algorithm to decide whether information is misinformation or not. So they utilize linguistic information, user information, and network features, and find some web pages that support information and utilize knowledge bases. But there are some problems about this method. So as I said, we cannot always consult with expert. And what if the information hasn't been manually examined yet? So in Snopes.com, they also rely on human effort. So it's sometimes difficult to cover as much information as possible. And lastly, so algorithms help, but can we judge the correctness based on style, feature, or common knowledge? It's sometimes difficult to judge whether information is correct or not based on just textual feature or the common knowledges. So here comes a main issue in my talk. So I want to introduce one alternative, not best solution, but one alternative today. So our approach is to believe in data. So we want to enable people to easily incorporate the data against the information chaos. So here I mean, by data, I mean statistical data, often provided as open data. So here are people, and they face some information. Then they might access to the statistical data on the web. And as the statistical data is very objective, doesn't include subjective opinion. So they can trust on data. We believe in data, and then they may judge these informations, whether these information are wrong or inaccurate or unreasonable. So that's one possible solution, I think. And I'd like to introduce some techniques related to this direction today. So there are some challenges. So one is it's difficult to access to these kind of statistical data, I think. So if you are asked to survey something, first you have to find some data. So is one of the challenge, because in information retrieval field, we often focus on document retrieval or text retrieval, but I think we have never explored some method for finding data, statistical data. Another issue might be, so we may examine some information, and then based on some reliable statistical data, we can provide evident information. So how to provide such evident information is another challenge, I think. And lastly, even though people can get some data to judge whether information is okay or not, the one problem is the data literacy problem, or data is very huge and it's very difficult to quickly examine the data. So we need some techniques for helping people interpret the data. So I want to go into the details about these three topics in the following slide. So first one is search, data search. So we try to find statistical data that support or oppose an argument. So here's one use case of our techniques. So this is a Macron tweet, the French president, and he said the Amazon rainforest, the lungs which produce 20% of our planet oxygen, he said so, but it turned out this is not true. 20% is a kind of overclaim. And if we look at some statistics, here's the oxygen production rate data, and we can immediately find, okay, this is too much, 20% is too much. And if we have very good techniques, then if we probably, for example, if user click on this 20%, we can probably find this relevant data. And then people can judge, okay, this is not correct, this is overclaim. So that's our kind of our view. Maybe we can realize this by doing some research on statistical data search. And second topic is producing data-driven rankings by various criteria. So when you submit the query to the web search engine, so documents are returned in response to your query, but they are not always based on the data. And when you find interesting ranking on the web, they are sometimes based on very strict criteria, very clear criteria, but sometimes they are just opinions of some limited number of people. So to solve such problem, instead of providing such very subjective ranking, we tried to produce data-driven rankings. So by data-driven rankings, I mean, if we have a camera, and the camera has these kind of numerical features, then if people ask this question, best cameras for hiking, then we rank these cameras based on these numerical features, not based on people's opinion. So this is one example. The other example is this. So safe country. So this is a query, and we want to find the country rankings. In the same way, we may produce this ranking based on their very objective features, numerical features. For example, we may use the police budget and crime rate for ranking these countries. And lastly, I'd like to introduce our trial to automatically summarize statistical data, I mean the visualization. As I said, it's sometimes very difficult for people to understand data. So if you are shown this tabular data, it's very tough to catch the meaning of this data. But if they are shown in chart, or if they are summarized by text, you can immediately understand what's the data meaning. But usually this was done by human expert, I think. If you have to understand data, and then you have to make this kind of chart, or you have to write this kind of description based on your understanding of data. So that requires a lot of effort. So we try automate this approach, this visualization or text summarization in our research. So in my talk, I briefly introduce these three kind of topics. Before that, sorry. Before talking about these three topics, I'd like to introduce a kind of side project from our teams. So I have conducted some research on these kind of data-related things, but at the same time, I was engaged in the developing data search engine for Japanese open data. So this is written in Japanese, but you might catch what is happening in this system. So we crawl and indexed Japanese open data, which include these kind of number of data set, maybe over 1 million data set. And if you type some keyword, then you can find such data set. And data set are provided by the local government or the research institute or the companies. And they scatter around the web, so it's sometimes difficult to find such data. So we developed this, and then so that people can easily find the data. I don't talk much about this, but this is the kind of side project we did. All right, let me talk about research. So the first topic is, as I said, data search. So finding statistical data that support or oppose an argument. And I mainly talk about a shared task we organized in NTCIR. It's a series of shared tasks. And this talk includes some the result of some paper. Yes, the one in CIR, the other is the NTCIR. So let me introduce the task first. So probably you may participate in the shared task before. And I found in the program of Rocling, you have a shared task session. And so I think you are familiar with these kind of shared tasks. And shared tasks, of course, have task description. And in our task, the task is give a textual query and find the most relevant data set. So this is similar to a document retrieval task, but instead of document, we want to find data set. And data set consists of a metadata of data set and actual data. So you can see, although these are small, you can see a kind of tabular data or structured data there. So instead of document, we want to find this kind of information. So what are queries? Queries are something like this. So I'm looking for evidences of domestic self-sufficiency rate of salt, or are there many people who can't drive large trailer, or how many people have a second house? So these are about the kind of statistics. And we assume that people issue a query like domestic self-salt rate, or people can't drive large trailer, many people second house. And given the query, we try to find the best matched data set. And we did this in 2 languages. So one is English, the other is Japanese. And we used kind of governmental information provided at this website. And we developed a kind of test correction or data set about data search. And I think this is the very first information retrieval data set for data search. And here are some statistics about this data set. We have this amount of data set, and we have around 200 queries for training and several dozen of test queries. And we judge the relevance of each data set for each query. And this, yes, these are statistics about our data set. And some of you may know about the data.gov, but I'd like to introduce what is data.gov. And if you go to this website, you can find many kinds of data in United States. And each country may have this kind of website, I think. At least US, UK, and Australia have data.gov something, data.gov.uk or data.gov.au. And they have very similar style, and you can find some data by typing keyword in this text box. And some examples are shown here. You can find some interesting data, like there is a lottery Powerball winning numbers. Maybe people are interested, bought lottery and they want to check the number, I think. And we can also find some trend like electric vehicle population data, because now the Tesla has become very popular in US, so people may have interest in the number of electric vehicles in the US. And they can check this kind of data on this website. But there are some challenges for the information retrieval task. So there are some difference between the document retrieval and dataset retrieval. So one characteristics of data search is that require the system try to find matching between text and data for some cases. So here's what we are given, the query, textual query. And what we want to retrieve is this information. So as I said, data set contain metadata, and metadata contain title, when it was published, and some short description, very, very short description about data set, and who developed this data set. And here is the actual data files. It's sometimes tabular data, sometimes JSON file. And as the metadata often lack details, as you can see, this description is very short compared to the usual text document. So not all keywords in the query may not match the metadata. For example, salt, this very specific keyword only exists in this data file. So if you want to find the best matched data, you also have to analyze this data as well. So this is the kind of challenge in dataset retrieval task. Okay, so I would like to talk about the shared task we organized. So we organized 2 rounds of MTCIR data search task, MTCIR shared tasks. So one was held in this period, and we have these participants in the first round. And at the second round, we had this participant. And I want to talk about some example of approaches the participant used. So one is BART-based relevant estimation. So I believe all of you are familiar with BART, and BART is of course used for information retrieval. And their approach is very simple. So we have a query, and we have data set description. You saw the very short description in the metadata. And they are concatenated and then input to the BART, and by using output for class token, we estimate the relevance. So this is yes, application of BART for information retrieval. This is a very typical use of BART in IR. And another techniques is to extract table headers. So you can find tabular data here, and you can also see the numbers like this. So not all part of the data are useful for indexing. So they extract this header information for indexing. So by doing this, they can incorporate the content of the data. So these are kind of some representative approaches. All right. So I want to briefly explain some results from NTCR 16, the latest round of our shared task. So here is our participant systems, and here NDCG are evaluation metrics for IR, and we have English result and Japanese result. And we get we found that for Japanese dataset, unfortunately, we cannot outperform baseline systems. But in English task, we found top performer, very clear top performer in English task. And I want to introduce their techniques. So this might be a kind of state of the art, I think. So they first try first stage retrieval. Let me explain why we need 2 stage. So in information retrieval, because we have a lot of data, we cannot apply BART for all the data because it requires a lot of time. So in usual IR system, we have 2 stage. So as first stage, we use very lightweight techniques like BM25, very basic IR techniques. And then we get top 100 data set, and they are sent to the second stage. And second stage, as you can see, is very complicated, but maybe the similar techniques are often used NLP, I think. The query and dataset description are sent to the GRU, and bidirectional attention was applied. And then these embeddings are finally concatenated, and they also use BART. Then these embeddings are concatenated and make some score representing document relevance. And this may be not very special architecture for NLP researchers, but interesting is that this model was trained with another data set. So this team have news and table pair correction. So they try to mine the Wikipedia tables and try to make a pair of news and table. And they have a lot of pairs of news and table data. And then they assume the news as a query, and table as a data set. They train this model with that data set. And then they achieve very nice score like this. So this is one example of data search algorithm. And so this was about the data search, and well, maybe I need to skip this slide, and I want to go to the second topic then. So second topic is the producing data-driven rankings by various criteria. So at this topic, I probably talk about the maybe first topic, and then go to the third topic. If I have time, maybe I talk about the second topic as well. So the topic has shifted to another topic. So the goal in this topic is to objectively answer questions such as which camera is the most portable, or which camera is the best for taking a photo at night. So to realize this kind of ranking, one possible solution might be we can rely on reviews at some popular website. If people say, okay, this camera is good for taking a photo at night, and the many people mention that, then maybe we can take it. But this might be a little subjective, I think. This can be biased by people's preference, I think. So what we want to do is to rank entities in terms of given criteria based on their numerical features. So camera, one type of entity, has these kind of features: size, weight, resolution, and f values. So based on these numerical features, we can make a ranking of portability, I think. So maybe in this example, portability might be measured by size or weight. So we can have very objective ranking based on these kind of features. Let me skip this slide. And but to realize objective rankings, so the problem is how to run rankings. And we sometimes do not have much data for running to rank. And first setting is a no training data situation. So there are many criteria to run cameras. Maybe some people say, I want to find a camera for hiking, or I want to find a camera for taking a photo of my children. There are many possible criteria, and we cannot find such rankings on the web. And it's very, it requires a lot of cost to make a training data for developing such data. So one approach, this sounds a little contradictory with what I said, but we can aggregate pairwise preference in reviews. So we actually rely on reviews, but finally, based on review, we run to rank cameras, but we only rely on numerical features. So we get some help from reviews, but we don't rely on review entirely. So that's the first thing I want to talk. The second thing is that we sometimes have limited number of training data. So I introduced example of best food in the world, but they only introduce top 50 food, best 50 best food in the world. So 50, this number is very small for machine learning, as you may know. So 50 food ranking is not enough for running something. So we need some solution, but this may be a little complicated. So let me talk about this later. And first topic. So what if we have no training data? So as I said, we rely on reviews. So we extract some knowledge from reviews. the knowledge are pairwise preferences between two cameras. So pairwise preference refer to the which camera is better than the other camera. So given a pair of camera, so this one pairwise preference indicate which one is better. And by using this kind of data, maybe we can run how to rank this camera. So that's our basic idea. So how to get such knowledge from reviews? So we rely on some patterns of description. So one pattern is, yes, as I said, pairwise preference. So if one camera is better than the other camera in terms of a certain criterion, then we get this pairwise preference. For example, so in review, if we find this camera is more portable than the other camera, so we can find this kind of description in the review. And we prepare several kinds of patterns that represent pairwise preference. And then if we find this camera, we get this pairwise preference. And we do this for many kinds of features. And the other type of knowledge we can get from review is a feature dependency. So this means, let me take an example. This means someone says this camera is portable as it is light. So they provide some reason why they think the camera is portable. So this can be used as a feature dependency. If weight is low, then portability is high. So this indicates negative correlation between two features. So we can also find this kind of knowledge from reviews. So you might wonder how we can use these two types of knowledge. The reason why we use these two knowledge is that we have one challenge. That is, you can imagine. So there are very few pairwise preference in reviews. It's not enough to train the model. So that's why we have two types of knowledge. The solution is that we infer pairwise preferences based on feature dependency to gain the size of training data. So if we have this kind of feature dependency, we can, if we have pairwise preferences like this, so this camera is heavier than this camera, and this camera is larger than this camera. And if we have this kind of feature dependency, we can infer this new knowledge, inferred pairwise preferences. And then we gain the size of training data. And finally, we can use these pairwise preference for ranking the cameras. That's our idea. And finally, I'd like to summarize the method used in our approach. So we extract some knowledge from reviews and make some inference to get this kind of pairwise preference. And then train the model, train the ranking model. And then finally produce a very objective ranking. So as I said, although we rely on reviews, subjective opinion, the final output is purely rely on the objective data, numerical data. So this is I think this is very evidence-full ranking. All right, so, and we did some experiment. I don't talk much about the detail, but we compare the product rankings produced by our method with expert rankings. And we evaluate our method with three test correction, so camera, smartphone, headphone, and we found that the inference and learning to rank worked very well, as you can see. The red ones are our proposed method. And the gray ones are frequency-based ranking. this is one method I mentioned earlier. So if you sort entities by congruence with portability, it doesn't work very well. So if you want to buy some camera, please do not simply rely on the review. That's our takeaway message from this research. Okay, so I think I have it. How many minutes do I have? Sorry.
15 minutes? 15 minutes?
15 minutes,
Yeah, 15 minutes. Yeah, thank you.
including Q&A.
Yes.
Okay, so maybe I will spend 10 minutes for my talk. So let me skip this topic, but I just want to introduce some findings from this research. So this is very similar to the one I mentioned. So I drag to skip, but I think this technique is very interesting, but let me skip. And finally, we tested with a real data set. And what I want to introduce is this. So these are real examples from our experiment. So we did experiment with country data and city data and the camera data again. And we found that this is a little kind of funny or interesting. So attractiveness of cities can be described by these the objective features of cities. So if the average lifetime of women is high, the city is attractive, or the traffic accident is very rare, then it's good. Or peacefulness of countries. This may be suspicious, a little suspicious, but a grain harvest and GDP growth rate have a positive correlation with the peacefulness of countries. And of course, number of suicide is a negative side of the country. So the peacefulness has negative correlation with the suicide. So with this equation, if you see the ranking, you can find, you can decide whether you can believe the ranking or not. Of course, some ranking has such a very clear criteria, but as you saw, we have many subjective ranking. So yes, this research have such situation. And lastly, so this is the last topic I want to introduce. So data summarization. So as I said, it's sometimes very difficult for people to understand data alone, statistical data. This includes many numbers. You may need some time to interpret data. So if people can easily access to data, it will not be useful if it is not understandable. But if they are visualized in an appropriate way, they are understandable, and people may use such information to judge whether they believe information or not. So our question is that can we do this automatically? So the goal of this research project was give tabular data, this kind of tabular data, and a visualization intent, such as trend distribution of crimes. We want to predict appropriate type of this visualization. So I think the participants of this conference have a lot of data literacy. So if you find this kind of description, you can immediately judge what kind of information should be used in this table, or what type of chart should be used to represent this kind of information. So we do this in an automatic way. So we want to predict the chart type, such as line or pie, or columns to be used. So from this data, we just want to use a count and year for line chart, and for pie chart, we just want to use a type. Sorry, and count. Sorry, we also have to use a count. So, but the question is how we can do that. So first we need a data set. So we crawled some data from Tableau public, and where users can upload tabular data and its visualization. And we crawled over 100,000 of tabular data and use it for training the model. And this Tableau data contain title of the visualization and tabular data and chart type and columns, which were used for visualization. So we have everything we need in this data set. And the title was used as a visualization intent. So our task is to produce this visualization based on the title and tabular data. And let me briefly explain our approach just for chart type prediction. So our basic idea is that we do some the attention technique. We use some attention techniques, and we incorporate statistical feature of each column. So here's the overview. Let me explain one by one. So here's the tabular data, and we have visualization intent. So as many NLP research do, we embed these kind of textual information by using standard word embedding techniques. So and these column header were embedded in this way, and visualization intent were also embedded in this way. And in addition, we have data here. In addition to the header, we have actual data under these headers. So we want to utilize this kind of information as well. So what we use is some statistical features of each column. So column include numbers, so we can take average, variance, standard deviation, or we can say whether it is a nominal scale or not. So this information is also helpful to judge the what type of chart or which column should be used. So we extract such feature for each column. And then we compute the bidirectional attention to find which information is necessary for predict chart type. So in this example, year and trend corresponding, and count and rate have some similarity. And we get high attention for these columns and terms in the intent. And finally, we aggregate this information to make a prediction. So that's a very brief introduction of our method. And maybe let me skip this slide, and I just briefly explain the experimental result. And what we found is, so this is a performance, and this is our method. And let one is our main proposal. And by comparing method with attention and without attention, we can see some improvement. And we also found that table alone or intent alone are not very effective, which means only given data, we cannot tell which one is good. And only given intent, we cannot tell which is good. We need both table information and intent information for better prediction. That's the main finding. All right, so lastly, I'd like to summarize my talk, and then I have some future direction to introduce. So I talk about one possible approach for misinformation or disinformation. So that is believe in data. Let's believe in data and have people to find such data or incorporate such data. That's the concept of this talk. And I have some future direction. Maybe we can discuss this. So can data always help? I do not think so. Data may sometimes help, but no, not always. Maybe useless for deepfake, echo chamber, and many other things nothing to do with data. So we need kind of collaborative effort for the problem of misinformation or disinformation. And of course, credibility of data, I said let's believe in data, but credibility of data sometimes suspicious. Especially Japanese government provides some wrong statistics that was reported by some years ago. So credibility of the data is very important as well. And also, it's important to convince or encourage people to think before consuming information. So education or mechanism design is necessary. So there are, I think, a lot of research opportunity in this topic. And there are also technical challenges. So because the Rocling is an NLP conference, let me try to attract you to some extent. So numeral is also an important type of linguistic expression, if I understand correctly. So this should be a relevant topic in NLP. And there are some recent efforts, including NTCR Finland. This is about some numeral analysis in the financial report or some other types of information. And we also have BART for tabular data called TABART or TAPAS. And we have nice survey. If you are interested in the numbers in NLP, maybe you can read this. And finally, textual summarization data is still very challenging, although there are many existing work. So the reason is that it also requires some data knowledge, data literacy. So I think BART is known as very powerful and includes some common knowledge by using a lot of textual data. But BART also need maybe data literacy if we want to produce better text summarization with data. All right, this is the end of my talk. Thank you for listening. And if you have a question, please feel free to ask. Thank you.
Thank you. Thank you so much, Professor Makoto Kato, for your wonderful speech. Any questions or comments from the audience? Any questions? We have 5 minutes for question and answering. Yeah, Professor Chen, do you have any questions for our keynote speaker? Thank you.
Okay, my question comes from the last part, the summarization of the data sets. My question is that can we use natural language generation techniques to represent the content in the data? Thank you.
Thank you very much for your question. So the question is that can we make text summary to generate for this program? Okay, so yes. So this may be related to the last thing I said. I know some trial that try to produce some textual summary of the data. For example, some people use basketball scores to generate a summary of basketball games. But if I understand correctly, so those researches are focused on one type of domain, one type of the one in the previous example, the basketball game was used. But I think it's very difficult to make a domain agnostic, domain independent textual summarization for data. In addition, some maybe text summary require statistical operation, such as taking a sum of the data, or taking a variance, or looking at the trend of the data. That's maybe is a very big challenge to make a textual summary, text summarization. So if we want to do such things, maybe only applying BART doesn't work. That's my opinion. Thank you for your question.
Thank you so much. Any questions or comments from the audience? Yes?
Thank you for your talking. We are from the AI Foundation, and we have some questions for the second topic. When you're doing your entity retrieval task, you mentioned that you retrieve some data from the reviews, and how do you make the pairs, and how do you do the labels of the two pairs? And when you are doing the inference, how do you do all the rankings? And another question is,
and the second question is that how can we get the data in the comparative sentence? Thank you.
Thank you. So for the first question, so we have two types of data. One is, yes, of course, training data, and the other is test data. And we use a different labeling strategy for these two types of data. And for training, maybe I have to say that is weakly supervised learning. So in the training data, we don't know the correctness of the labels. So we just guess that is possibly correct. And how we did is, yes, that's very simple actually. So if we find this pattern of reviews, pattern of sentences in review, then we think this pairwise preference is true. So nobody knows this pairwise preference is actually correct or not. So that's why I said this is a weak supervision. This is a 1 point, I think. So we just use entity names in the review and language expression. That's it, very simple. And for test data, this is maybe also interesting. So we bought some magazine about cameras, smartphone and headphones, and we scraped the expert rankings from this magazine. And we believe that that is, also that is based on some limited number of experts. So that can be kind of reliable, the information. So for test data, we are sure that is somewhat correct. So that's the answer for the first question. And for the second question, so how to get the data from comparative sentences? I think that is a second question. But I think if I understand correctly, I have already answered that question. We just use simple language patterns. So if the sentence is written in this way, is more portable than something, then we think this, we label in this way. So that's the answer to the second question, if I understand correctly.
Because time's limitations, I have last questions for Professor Makoto Kato. Because you and Professor Xinxi Chen from National Taiwan University are organizing SIG-IR 2023 in Taipei for next summer. My question is that, are you coming to Taipei in person to organize SIG-IR 2023? Are you coming to Taipei in person?
For not being there in this time in person, I'm sorry about that. But next year in July, I definitely go there and I will enjoy Taiwan. Thank you very much.
That's all for this keynote speech. Thanks Professor Makoto Kato, our keynote speaker. A round of applause again. Thank you so much. Thank you. That's the end of the keynote speech. Thank you so much.
好，那我们结束了这一场的这个 keynote speech 哦，那